Good morning, everyone.
Good morning, sir.
Good morning, sir.
Yeah, so we'll start with this gauge glass fitting. All right. Very quickly, we are going to go through it. So, classification society requirement is that at least two gauge glasses must be fitted. Okay, and they should be independent of each other. That means operation of or failure of one should not render the operation of other one. So, two independent, separate gauge glasses are required to be fitted by the classification society. All right, that is the primary requirement. Now, different gauge glasses are available in the market. Okay. Depending upon the capacity, working pressure of your boiler, multiple different types of gauge glasses can be installed. For example, tubular type of gauge glass. So this is generally applicable for very low pressure boiler. A simple tube. Okay, simple tube is provided here. All right. Like आपका हाइड्रोफोर वगैरह में लेवल मेजर करने के लिए होता है ना, सिमिलर काइंड ऑफ अरेंजमेंट विल देयर. ठीक है, बोथ साइड विल बी सील्ड विद द packing rings and all these things, and there is possibility that this kind of gauge glasses can rupture very easily. So guard has to be provided, protective guard has to be provided around the tubular type of gauge glasses. All right, another type is this is reflex type of gauge glasses. It is used for most of the modern boilers. In this one, you are going to have the glass. Okay, reflex type of glass is there, and this is generally applicable for your medium pressure boiler, and this works on the refraction of the light. Okay, so level
reflex मतलब क्या हुआ exactly?
It works on the principle of refraction. ठीक है, जब पानी का लेवल है ना, ठीक है ना, sometime it becomes difficult to identify the water level. So this particular arrangement see here, plate type of water level gauges can be used for low pressure. In view of their greater cost, they usually only come into general use for pressure above 17 bar. The reflex glass is an example of type of water level indicator suitable for boiler of medium working pressure. These gauges are supplied with gunmetal bodies. Okay, and while high pressure, 4 steel bodies are also used. The gauge is normally fitted directly to the boiler shell or the steam drum. The isolating cocks in the steam and water connection together with the drain cocks are of the asbestos sleeve type. वहाँ पे उसको sealing is given on the both side of the cocks. In many cases, these cocks can be operated by extended rods or chain. There will be this remote operation, isn't it, with the help of the pulling handles and the cables. All right, so that in case you require to carry out gauge glass blowdown, you are not required to stand next to the gauge glass. Okay? You can do it from the remote location as well. That is to enhance the safety of the operators, okay? To prevent the injuries in case the glass is going to shatter. Okay, the single sided glass ingeniously makes use of the refraction of the light so that when illuminated from the front, the series of ribs at the back of the glass plate causes the light rays to be reflected back from the steam space and absorbed in the water space. This gives a bright silvery appearance to the former, while the latter shows dark. Okay, तो इसका refraction, okay, light का जो refraction होता है ना, you must have seen, anybody have seen the glass, it is have ribs.
Yes, inside.
Yeah, ribs are there. Because of these ribs, the refraction of light is going to be there. So identification of level is going to be वेरी इजी इन दैट केस, ठीक है ना, क्योंकि आपको थोड़ा दूर से भी लेवल आपको दिखना चाहिए, ठीक है ना. And if you see another type is that which is applicable for very, what can say, high pressure boilers. Generally they will go for the double plate type water level gauges. What is the question asked in the MMD examination? They are not asking you detailed explanation about different type of gauge glasses. Just they are asking you what is the type of, or what is the different types of gauge glasses used in the boiler. तो आपको खाली नाम मालूम होना चाहिए, ठीक है ना. Tubular, reflex type of water level gauges and double plate type water level gauge. यहाँ पे double plate क्यों दिया है? For additional safety and protection, ठीक है. There will be two glasses. There will be two glasses, and in the middle there will be hollow space where the steam and water is going to be present. Okay. Then sometime surveyors are also going to ask you.
These double plate types of water level gauges are used in high pressure boiler, right, sir?
Yes, for high pressure boiler, okay? Not normally for medium pressure boiler. Anybody have seen double plate? Generally नहीं रहता ना. The reflex type of gauge glass is mostly widely used. ठीक है? It is just going to provide additional safety. High pressure boiler के लिए उसका strength will be higher. And if you look here, sometimes the surveyors, very rarely, but sometimes they are asking, is there any possibility of remote measurement of boiler level or remote observation of the level in the boiler? Yes, in that case, some boilers, okay, not the modern boilers, but the old boilers were fitted with something called as AGMA type remote reading water level indicators. What is the purpose of this? You can monitor the level from the remote position. So this part here, indicated, जो आपका indicator है, that will be located in a remote position. So one connection is taken from the steam drum, and then you are having here a weir. Okay, weir. Weir में क्या होएगा? The steam is going to condense and it is going to become water. Okay, and then it is going to overflow into this arm. There is another arm also which is connected to the water drum. Okay, now, and then there will be also a liquid is going to be filled here.
Yes, sir. Colored, red colored.
Color liquid ना, indicator fluid is going to be filled in this. तो यहाँ पे color liquid रहेगा. अभी क्या होएगा? Because of the differential density will be different. Yes. Where will be the different density? Depending upon temperature, isn't it? What principle it is using? इधर क्या आएगा अभी? This is going to be distance x. Then this is going to be your distance y. Here, ये जो level है, this is going to become your x dash. And then this remaining distance is going to become y dash. The working principle is x into d. What is the d? D is the density of this side. हाँ? और क्या आएगा? देखो इधर क्या है? हेड क्या है आपका? x into d, हाँ, plus y into d. What is the y into d? d क्या है आपका? ये जो लिक्विड है ना, इसके अंदर में इंडिकेटर लिक्विड डाला है, उसका डेंसिटी आएगा. ओके, so this side equation is like this. What will be the other side equation? x into d, x dash, sorry, ये distance, plus y dash into d. So there will be density difference between the indicator fluid and the density of your water, okay, condensate, and then it can be multiplied by the height, and then you will be able to identify the difference in the water level, okay, difference in the water level. So that is the working principle of this particular type of glasses, and generally these are used for remote identification of the level. The heavier density fluid will be always proportionally displayed in this particular U type of column. यहाँ पे जो column है, you will see that this is your U type of column. तो यहाँ पे क्या होएगा, जिधर भी density ज़्यादा होएगा, wherever density is going to be higher, that side will be more head. Okay, the side which is having lower density, that side head will be less, and due to that density difference, you will be able to determine the level at remote location. Okay? Remote location. So this part here is remotely fitted. ये वाला part remotely fitted. Okay, not on the boiler. And then there will be two legs. Okay, this is your one leg from your steam side. There is another leg from the water side, and then the water is going to be condensate. Okay, from both sides is going to be fed into this particular gauge glass. Okay, and that is how you will be able to determine the level. Clear with everyone? आपको explanation कोई नहीं पूछेगा, आपको खाली मालूम होना चाहिए कि how the sometime they ask you ना कि remote level observation के लिए क्या करेंगे, तो then there will be this HMR type of remote reading water level indicators on some type of old boilers are provided. Now coming to the important question, what will be asked in your gauge glass is the tightening sequence. Okay, tightening sequence पूछते हैं आपको, and the safeties of the gauge glass. So tightening sequence, if you are going to have uneven numbers, then always the tightening is going to start from the middle, and then it is going to move outward. Okay, from the center it will move outward. In case of even numbers, you are going to start like this, again from the center, but in a crosswise manner. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. In the uneven case, 1 2 3 4 5 6 7 8 9 10 11 12 13 14, like this. So
Even में भी
always
same ही है, right sir? Cross में भी.
same है, it has to be same only in a crosswise manner. लेकिन uneven में क्या होएगा, एक आपके पास ज्यादा है ना, yes, this side is for example 6 and this 3 and this side is 3, तो you are going to जो बीच वाला है उसको parallel tight करो, and remaining you are going to tight in a crosswise manner, starting from the middle and moving outwards. Any larger gasket, any larger flanges always required to be started from the middle. हमेशा middle से ही आपको बाहर जाना है. Understood? Always you required to go from the middle to outward. That is the proper procedure for tightening any large gasket, any large flanges. So that same principle applies for your gauge glass also. You are starting from the center, and in a crosswise manner you are going to move outward. The gauge glasses can be tightened in multiple steps. The torque will be given in the instruction manual. Okay, so this is one of the instruction manual. First tightening torque is 20 Newton meter, second tightening torque is 35, and last tightening torque is 45 Newton meter. All right, so it can be started in multiple stages. Very important step, after overhauling your gauge glass, when you are going to assemble it, you have to only hand tighten it. After hand tightening, you are going to put the glass on the boiler, connect it to the boiler, and you require to let it be in that condition for at least 30 to 1 hour. Okay, why? because it has to come to the same temperature as of your boiler. If you are not allowing it to come to the same temperature and you are going to tight with the torque, so when it is going to expand, the actual torque is going to be very high. So पहला क्या procedure? After overhauling any gauge glass, you are supposed to assemble and tight with only finger tightening, okay? No torque tightening. Then assemble on the boiler, let it come to the same temperature of your boiler, and then you start to tight in a multiple steps and final torque tightening. Okay, that will ensure that at the end of the tightening
तो सर
procedure,
कितना टाइम तक लाइक अपना विदाउट टॉर्क अपना बॉयलर पे रखना है उसको फिट करके
this 30 minutes to 1 hour, yeah, that will be sufficient.
इन फायरिंग नॉर्मल राइट नॉर्मल सर
Normal condition. See, boiler is always heated, isn't it? Hot रहेगा, तो अपने आप ही gauge glass will also become heated.
सर ईवन का कैसे शुरू करेंगे सर? ईवन का टाइटनिंग सर,
क्या होगा?
ईवन का टाइटनिंग कैसे शुरू करेंगे सर? हॉट का तो क्रॉस मिडिल कर
One
देगा
का tightening ऐसे करेंगे ना. This is your first, you are going to tight. Second, third, fourth, fifth.
ओके,
sixth.
मिडिल से किधर भी जा सकते हैं सर?
ये मिडल से चालू किया ना हमने, isn't it? Crosswise from the middle.
ओके
Crosswise ही रहेगा हमेशा. Okay.
ठीक.
From middle to outward. ठीक है ना? और ये tightening करने के बाद में you have to let it come to the temperature and then only you are going to tighten with the torque. ठीक है? Now, when you are going to open your or dismantle your gauge glass, important maintenance is going to be regarding your glass itself. Generally, this glass is going to be made up of borosilicate material. Borosilicate material. So, what type of defects you are going to be expected here? There will be possibility of pitting and wire drawing effect. यहाँ पे ऐसा glass will be damaged. So if you don't have spare, you can always do the lapping of this damaged glass on your lapping table, okay, with a very fine paste. Only if you do not have spare glass. Otherwise, it is always recommended to use the new glass. And most importantly, the glass is always protected by the mica sheets. Okay, on both the sides there will be
this for pitting and wire drawing.
pitting रहेगा ना ऐसा
Yes sir, yes
dents
sir.
आता है, हाँ, pits. Okay.
So what we have to do like polishing
If you don't have spare, then only. Yes. If you don't have spare, take the glass to the lapping table and you can do the lapping and you can reuse. Okay. In case only if you don't have spare. It is always recommended to go with the new one. Okay. In all condition. लेकिन नहीं है तो we can reuse by lapping it. All right. Also, these gaskets are very important. Okay. If you can see here, the gasket on either side, this gasket, these are the preformed joints, special material. Okay, high temperature graphite embedded gaskets will be there, and also on both the side of glass, there will be something called as a mica sheet. Okay. Anybody have seen the mica sheet?
Yes, sir. Sir, I changed this sheet. There was a boiler, they were broken. Sir, but one point, sir. One mica sheet was there, and there was one other material, sir. Some softer material, some different type.
Cushion sheet.
Cushion sheet, yeah.
Gasket.
Why is
So
it, sir?
that see क्या होता है ना? See, during your pressure, when pressure is going to increase, what will increase? Temperatures are also going to increase. So some allowance for the expansion has to be also provided. If you are not going to provide any expansion allowance, the glass is going to crack because of excessive stress. So some cushioning arrangement will be embedded additionally, or it will be taken care by the gasket itself. Okay, so that is the purpose. So here minimum 2 requirements are there: heat resisting gas material, gasket material, okay, and mica sheet. Mica sheet का क्या function है? The mica sheets are placed over the glass surface facing the water and steam side. The mica sheet is necessary as high pressure hot distilled water is going to cause the erosion of your glasses. Okay. So to protect your glasses from the effect of erosion due to the high pressure distilled water, and also there will be chemicals added into the glass, so that will together is going to attack the glass and it will cause damage to the glass. And to protect your glass from this effect, negative effect, the mica sheet has to be provided on either side. Okay, so unless a sheet of mica is placed between the glass and water, attack will take place very quickly. Indeed, at high pressure range, the glass will burst within a few hours if the protection is omitted. When bolting up this assembly, care must be taken to ensure even and sequentially all-round tightening of the bolts. Failure to do will also result in leaking assembly and possibly shattered glass plate. Please take the screenshot of this one. So that is the purpose of the mica sheet and significance of even, sequential, crosswise tightening starting from the middle, moving toward the outward, need to be done in a multiple stages. Precaution has to be taken to ensure that the tightening has to be taken place after allowing sufficient expansion. Okay, so it has to be mounted on the boiler and let it come to the temperature of equivalent to the boiler.
One question is asked when you are taking this gauge glass to the workshop and how you assemble, and yes, and another one question was what you will do if spare is not available. So that is okay. Lapping is done, right?
So
Sir,
workshop
for
में
the
लेके
gasket,
now, हाँ,
sir, for the mica sheets and the cushioning gasket, they are both different gaskets. Sir, if you don't have the spare of that gaskets, then can we use the
for
this one
emergency
spring
purpose
gasket?
you can use your high temperature
Spring gasket,
graphite embedded gasket. Okay, you can use that.
graphite embedded gasket. Okay. And sir, one more thing. Sir, there is when the on the glass holder, on the gauge glass holder, there are some fitting marks on the holders. I mean, behind the glass, not in the glass, because we have spare. So we'll change the glass and the gasket. But on the surface, sir, there is always fitting marks over there. It was old shape. So every time I used to overhaul the gauge glass and fit it back with everything on order. But after 1 month or 1.5 months, gauge glass started to leak.
What you can do, you can always, wherever you are having pitting on the holder, you can high temperature putty. Okay, you can apply high temperature putty and you can finish. Okay, properly finish karo and then try to assemble. Okay, that will resolve the issue. क्योंकि वहाँ पे
Sir,
welding
if we use
repair
the
नहीं करता.
Welding
sir,
possible
if we
नहीं है.
use the putty, will the surveyor accept it?
पुट्टी किधर यूज करना है सर? नॉट ऑन द ग्लास.
जहाँ पे रख रहे हैं उसको ग्लास को यहाँ पे रख रहे हैं गैसकेट के पीछे
Holder, glass holder.
होल्डर पे ग्लास होल्डर पे.
Okay.
Here, this is the qualities of your most of the glasses what you are using. See, the material is going to be borosilicate glass. It is thermally pre-stressed. That means it is having certain properties to resist the thermal resistance. Okay, so uska resistance to bending strength, then mean coefficient of linear expansion, transition temperature. So up to 550 degree temperature it is convenient for usage. Then it is alkaline resistance, it is water resistance, it is acid resistance. Okay, so यहाँ पे सब कुछ दिया है. So this is from the one of the makers. Okay, Klinger करके एक maker आता है. Okay, they are very famous maker for your side glasses or gauge glasses. Mechanical strength. Okay, then mica protection. mica shield must be supported by glass with perfectly flat surface. Therefore, only transparent glasses can be mica protected. This is not possible for glasses provided with reflex grooves. As Raisley mentioned, gauge glass must be mica protected on side facing the medium when used with the steam pressure over 35 bar. Okay. लेकिन हम लोग देखते हैं कि मीडियम प्रेशर बॉयलर वट एवर बॉयलर्स वी आर यूजिंग स्टिल वी आर हैविंग माइका शीट प्रोटेक्शन. ठीक है ना. Okay. One more thing. That additional safety. What is the safety of gauge glasses?
Steel ball.
If you look into the
Steel ball.
self-closing steam ball will be there. Okay, self-closing steel ball will be there. What is the function of this steel ball?
It acts as a non-return valve.
Non-return valve, sir.
Glass scattered.
Yes. So what is going to happen? See, look at the first picture. Ball position during commissioning or flushing or purging. Ball position during normal operation. Okay. And the moment it is going to get shattered. So what is going to happen? Glass and mica sheet is going to break. And that ball is allowed to move and it is going to block the passage of your incoming water. Mostly the protection on water side is required, not on the steam side. The reason is that when that heated water is going to be exposed to the atmospheric condition, it is going to immediately flash up and convert into steam, and that steam is going to occupy larger volume. Okay. How much is the expansion ratio? I am not sure about it, but it is I think more than 600 times.
Sir, please once again you tell me, sir, again this.
See, इधर से इधर रहेगा वो, ठीक है, वो ball इधर रहेगा. So let's say your glass is shattered. When the glass is shattered, what will happen? The ball is going to block this passage. So water is not able to come out. What will happen if water will start to come out? The water is already inside boiler is under pressure and at some temperature. So when that water at that temperature suddenly exposed from high pressure to the atmospheric pressure, what will happen? Boiling point is going to decrease drastically. So the water will start to convert into steam. It will start to flash up. And when it is going to flash up, it is going to occupy large volume of your engine room. It is going to engulf entire engine room within few seconds. सब जगह steam आ जाएगा. And then that can be a serious safety hazard. It can cause severe injuries to the person operating around the boiler, or it can even though cause certain damage to the surrounding machineries as well. So to enhance the safety, gauge glasses are required to be provided with this steel ball on the water side, which is called your self-closing ball. Okay. So in case of the glass is going to shatter, it is going to block the water side. Okay. Water will not allowed to come out. Clear?
Okay, sir.
सर ये कैसे
Another
काम
thing-
कर रहा है? काइंड ऑफ प्रेशर नहीं पड़ेगा, मतलब
कैसे काम कर रहा है? अभी क्या होता है? There are two things. One, differential pressure. Okay. When glass is going to break, what will happen to on the pressure on the side, top side?
रिड्यूस
Sudden
ऊपर में प्रेशर कम हो जाएगा. नीचे में प्रेशर is the pressure acting from the boiler. So because pressure is going to increase on the bottom side, the ball is going to be forced
ओके
upward.
ओके
Also, when glass is going to shatter, in some cases, especially you look here, this arrangement here. When the mica sheet is going to break, or this glass is going to break, what is going to happen? The pressure. तो pressure difference की वजह से क्या होएगा? mica sheet break होएगा तो क्या होगा? This arrangement will be pushed inward, okay, especially for this glass, and then the ball is going to close, or it is going to sit on the seat. Normally in this case, look in the picture figure 1, where the glass is intact, the mica sheet is intact. This will not allow the ball to reach the sitting position. But the moment, okay, the moment what will happen? It is going to rupture.
Pressure
उस
difference.
time पे क्या? हाँ, it is going to reach there. Okay, so some
सर ये
design
steam side क्यों नहीं है?
steam side में जरूरत है ना, steam is going to come and steam is going to remain steam only.
सर
Yes,
बट फिर
it
भी
is not,
आइसोलेट करने जाएंगे तो वेरी हाई प्रेशर स्टीम और डैमेज नहीं हो सकता कोई पर्सनल?
नहीं, उसके लिए तो रिमोट लोकेशन पे दिया हुआ है ना, another safety measure, isn't it?
यस सर यस.
So actually in modern boilers, okay, some boilers you will find that self-closing ball is going to be provided on either side. But for MMD examination, they will ask you regarding only this side. So please remember why it is provided on the water side, due to the expansion and flash up of the incoming high temperature, high pressure water subjected to atmospheric pressure. Then there will be some remote arrangement will be there for operating your valves from the remote location. Yes or no? So that operator is not required to stand next to the gauge glass and operate this valve. If
यस सर वो
sometime
बर्नर के पास
the
है.
glass is going to shatter, so it can cause burn injuries. Okay. So another safety is remote operation. Okay. यहाँ पे आएगा आपका self closing steel ball. Another safety is that if you look into the water side and the steam side handles, they are always facing vertical downwards.
Downwards.
And drain also, right, sir?
And they will be in open position. So vertically downward means open position. Drain is also facing vertically downward, but that time it will be in a closed position. Okay. So that is also a safety part here ना, क्योंकि vibration के वजह से wall आपका बंद हो जाएगा. If you are going to give the handles in a horizontal position, due to vibration, they are going to close. So your gauge glasses are not able to show you correct level. उस वजह से क्या करें, उसको vertically डाउनवर्ड करेंगे. ठीक है, बोलो और क्या क्वेश्चन है गेज ग्लास का?
सर इसमें और ही फिश रहती है क्या कुछ सेफ्टी के लिए? नहीं ना, यही बॉल रहती है बस.
बॉल ही रहता है ना, दैट प्लेट.
सर इसमें एक लेब्यूर प्लेट है सर, उसका काम क्या है बता दीजिए थोड़ा सा.
कौन सा प्लेट?
सर लेब्यूर प्लेट, LOUVRE.
येलो
फोटो में UVRE. सर इसमें सर डबल प्लेट टाइप में सर.
लॉवरिंग प्लेट.
यस सर, डबल प्लेट में. हाँ ये सर.
सर वो बेसिकली वही है जिससे लाइट रिफ्लेक्शन में हेल्प मिलता है, उसी को
हाँ,
बोलते हैं.
वो क्या है ना, उसमें कलर प्लेट ब्लैक एंड व्हाइट strips are going to be painted. ठीक है ना, black and white alternating strips are going to be painted on that plate. So when the operator is trying to look, the level can be clearly visible. Okay, that is the purpose there. उसके ऊपर देखो मार्किंग है, ब्लैक एंड व्हाइट का अल्टरनेटिंग मार्किंग विल बी देयर.
ठीक है सर.
तो जो क्वेश्चन था वर्कशॉप में, जैसे लाइक व्हाट हाउ वी विल असेंबल रीअसेंबल,
वही करना है सर. सी यू रिक्वायर टू चेक द कंडीशन ऑफ योर all the back plate. You are going to check the condition of your glass. Okay, you are going to check for the pitting marks, wire drawing. Okay, na, any physical damage. You are going to check all the walls. ठीक है ना, आपका वॉल्व में क्या करना पड़ेगा, दिस कॉक्स आर रिक्वायर्ड टू बी, उसका सीलिंग चेंज करना पड़ेगा. ग्राफाइट सील्स आर देयर, दिस सील्स आर रिक्वायर्ड टू बी चेक. if you are having these plugs, make sure the plugs are going to be properly tightened. That is general inspection. Nothing very special about it.
ये सर जो लोअर प्लेट बताया सर उसका यूज एक बार फिर से बता दीजिए.
So then we have to change like this sealing gaskets and cushioning sheet, right, sir? Every time. Mica sheet.
आपको किसका यूज चाहिए सर?
सर
लोअर
लोअर
प्लेट.
प्लेट.
Write down. The lower plate at the back of the gauge is placed.
सर ये कौन सा प्लेट लिखा सर आपने?
LOUVRE. We placed actual level in the glass appears as a plane okay. So there are two arrangement. Okay, this plate which is positioned at the back of the gauge glass is going to have slots like this. Okay, or it can be painted in black and white color. Okay, इससे फायदा क्या होता है? If somebody is standing down and is looking at the glass, because of this particular refractive patterns, when somebody is looking at the gauge glass from the down, he will be able to see the level correctly. Normal gauge glass, if you are looking the level from down, it will be not possible to see it. But in this particular double type of, okay, double glass type of or double plate type of water level gauge, you will be able to see that one. Okay, now that is the advantage here. So these are the either slots or stripes of white and black paint. Understood?
Yes sir. Thank you.
Sir, I was asking like reassembly, like so we have to change the ceilings, gaskets, right, and
तो
mica sheet.
आपको मेंटेनेंस में क्या करना है? In maintenance of, okay, write down. Check the body of gauge glass for pitting and wire drawing damage. And body is made up of either steel or monal metal. Okay. Second, check the condition of gauge glass, if required, lapping can be done in case no spares are available. Third, change all packings and mica sheet before assembly. Change gland packings of all the cocks. Assemble and install on boiler. Let it heat up for the period of 22 minutes to 1 hour. Follow the tightening sequence and tightening torque sequence in alternating crosswise manner, starting from middle to outward. Sometimes they can ask you for even and odd. What is the difference?
Sir,
Odd में
uneven
क्या रहेगा?
1 2 then all cross and even
इवन में ऐसे चालू हो जाएगा सीधा. ऑड में कैसे रहेगा?
1
ऐसा
2
चालू
straight
रहेगा.
then cross.
And stepwise torque tightening करो. That is it. Okay, that is it. Now another question asks why during blowdown water is open first. Okay.
Specific enthalpy.
What is the reason for water is being open first?
Steam has higher specific enthalpy, sir, as
Sir,
compared to
so
water.
that the water once it comes down, so that we can identify that gauge glass is free from the vicinity. Vicinity is clear.
So there are multiple things. First is thermal shock. Suddenly, if you are going to open steam, what will happen? As somebody is mentioning, the specific enthalpy of steam is very high. That means it is going to have more energy, isn't it, compared to water? So it is going to suddenly hit your glass and it can shatter the glass. Second, you must have observed that any place, if you are going to open vapors first, okay, अगर steam डालेंगे and then you are going to admit the water, possibility of vapor lock is there. Okay. So what we are doing, we are always following the practice that let open the water first, let it fill the entire column, okay, gradually, and then we are opening the steam. So steam is going to press this water down again and it is going to settle at a correct water level. Okay. तो दो चीजें, एक तो थर्मल शॉक की वजह से आपका ग्लास टूट सकता है और दूसरा है कि
But it
vapor
is
lock हो
very
सकता है.
strengthened and hard material, no, sir. That I agree. There is definitely some thermal shock is there. but it is a high temperature material, no sir, withstanding material, sir, that one.
But sometimes some practices start from very long time before, no? Isn't it? You can have a superior material at this time, but gauge glass is from very long time, na? So some practices has been carried out, isn't it? आप अगर स्टीम ओपन करोगे तो क्या होएगा? कुछ नहीं होएगा अभी के ग्लास के लिए, लेकिन the glasses which are used in the earlier boilers,
Okay, sir.
so they made these practices to avoid the damage, isn't it?
Okay, sir.
Okay, चलो आगे चलते हैं. Let's move to the next part. Is the how the level.
Sir, please wait, sir. The one line try to write.
Sir, can you move the screen down now? Sir, down. सर वो वेपर लॉक वाला एक बार फिर से बता दीजिए.
It is normal phenomenon. अब किसी भी जगह पे अगर आपका वेपर आएगा तो sometime liquid does not have potential to press it. Okay, understood.
Okay.
So it is not able to displace the vapors and then it is going to cause vapor lock. तो उधर वो पानी का लेवल बढ़ने में टाइम लगेगा and it may be not a true representation of boiler level. Okay, so these are the things.
Yes,
Now
sir.
in your boiler, see, additional to gauge glasses, there has to be requirement of some other form of electrically operated additional water column will be provided and fitted with either float wall and multiple magnetic micro switches, which is useful in determining the level as well as giving the alarm. Gauge glass doesn't give alarm, isn't it? Gauge glass itself is not going to give alarm. So additional to the two gauge glasses, the boiler is required to fitted with some means of level indicator, which is also going to generate alarm. So this is the Mowbray float type of. Mowbray is the company or brand. Float type of level indicators are there. The construction is a simple column is there.
सर ये गेज ग्लास से पहले लगा होगा.
नहीं, additional to the gauge glass sir.
Okay.
क्योंकि gauge glass से आपको कैसे मिलेगा alarm? नहीं मिलेगा ना. So some for low level alarm and high level alarm and trip and all these things, some additional system has to be incorporated. So this is the float chamber. In the float chamber, this is the float with certain buoyancy, and then you are having your water. This is your water level. Okay, and there will be extended arm to this main float, and on the bottom again there will be small float, which is magnetic in the nature. And outside of this float chamber, there will be 4 micro switches provided, magnetic micro switches. Whenever level in the boiler is going to reduce, the level will also drop in this particular float chamber that allows this magnetic float to move down. And whenever it is going to come in a contact, in a magnetic contact with the magnetic switches, for example, when the water level is going to drop, niche aayega, it will come down. So it is going to give the low level alarm. The circuit is going to get completed and it is going to generate low level alarm. Further decrease in the level, the small magnetic float is going to move further down and it is going to give you the low level trip. Similar way, when the level is going to increase, what will happen? High level alarm and high level trips are going to be provided. Okay. Also, the same thing can be utilized with the help of your solenoid relay. You will be able to cut off the fuel also. Okay. So you can utilize this particular arrangement in multiple ways to cut off your fuel, and in some cases you can even use it to operate your feed water controllers. Okay. You can do that one. But the problem with such kind of device is that if the float is going to get corroded, it will lose its buoyancy, and that time it may not able to give the correct indication of level. It will be not able to give the correct control. Low level alarm, high level alarm, and protection for your boiler may not be adequately provided. इसमें होल हो गया तो क्या होगा? It will lose its buoyancy. Isn't it? So that is the difficulty with such kind of control system, level control system, and that is why most of the modern boilers you will find there will be DP transmitters. Okay, DP transmitters fitted. Now these DP transmitters are able to detect the level, and they will be able to generate the alarms. They can be used to trigger the safety system, that means safety and shutdown system. So multiple uses can be taken with the help of DP transmitter, and the possibility of damage to this float is also going to be eliminated. Okay. So let's try to. देखो आपके बॉयलर में क्या रहेगा, 2 गेज ग्लास रहेगा. Okay, there will be 2 gauge glasses. Additional to the 2 gauge glasses, there will be float type of level indicator. Okay. In some boilers, additional to this, DP transmitter will be there, or this will be not there. 2 gauge glasses plus DP transmitter will be there. Understood?
सर डीपी ट्रांसमीटर से सेफ्टी भी हो जाती है, सेफ्टी कटिंग कट ऑफ.
Yeah, we'll talk about DP transmitter. Yeah, अभी बात करेंगे DP transmitter में. ठीक है. What is the working principle of DP transmitter?
The difference in capacitance.
Difference in capacitance. Is it measuring difference in the capacitance?
Difference in pressure.
Pressure. Displacement in strength, sir. Differential pressure.
Differential pressure, sir. Differential pressure it will measure.
There will be so there will be a diaphragm, and across both sides of the diaphragm, a pressure is going to be applied. Now, a pressure is going to be same. There will be no deformation in the diaphragm, and this diaphragm is connected to strain gauge. Then strain gauge is going to generate the output signal of 4 to 20 milliamp. अभी जितना ज्यादा डिफ्लेक्शन होगा उतना ज्यादा सिग्नल बनेगा. So there will be, if the pressure on this side is going to be higher, the diaphragm is going to deflect to this side, and depending upon the deflection, whether it is positive deflection or negative deflection, the strain gauge is going to generate the signal depending upon differential pressure. As differential pressure will keep on increasing, uska signal will vary. Okay, that is the concept here. So in the DP transmitter arrangement, look at this
Sir, how
picture.
this differential pressure will create, sir?
We'll come to that one. Just a moment. अभी इतना ही याद रखो कि differential pressure is going to cause the deformation in the diaphragm plate, and in that respect, it is going to cause the difference in strain on the strain gauge. And strain gauge का क्या काम होता है? What is the function of strain gauge? It is going to measure the degree of strain and convert that degree of strain into proportional output signal in the form of 4 to 20 milliamps. In this case, you will see that this is the general arrangement for your boiler DP transmitter. There will be one connection from the steam side. There will be one connection from the water side. This is, we are talking about steam drum. Okay, ये किसके बारे में बात कर रहे हैं हम लोग? We are talking about steam drum. Now, here, first you are having this. What is the name of this part?
Variable legs.
Condensing pot.
Condenser pot. हाँ.
Condenser pot.
Condensing pot. What is the
Measuring.
function of condensing pot?
सर वो स्टीम जो निकले उसको कंडेंस करके लिक्विड फॉर्म में ही रखेगा.
जो भी मेजरमेंट होता है इसमें वाटर की फॉर्म होता है, स्टीम में, इसलिए कंडेंसिंग वाटर,
So it will be on engine room temperature.
ताकि वो स्ट्रेन गेज खराब ना हो, एग्जाम खराब हो सके.
यहाँ पे देखो, what is the theory of condensing pot? Is that between the process tapping and the pot is the steam vapors. Between the pot and the differential pressure transmitter is water. So one side, what is there? Steam. One side you are having water. So if you are allowing steam from one side to act on the DP transmitter and one side you are allowing the water to act on the DP transmitter, do they have same density? This
No,
side
sir,
is
no.
steam
No.
and this side is your water. They don't have
Cold
same
water.
density. So how your DP transmitter is going to measure? DP transmitter is supposed to measure fluids with the same density. Then only there will be logical analysis of the level or something like that, isn't it? So in this case, the concept of condensing pot is that its name suggests itself. Whatever steam is there, it is going to be condensed, and this side of the column is also filled with the condensate. That means it will be also liquid. This side will be also liquid. So because of this, measurement in the errors can be minimized. Please write down. First thing, the requirement of condensing pot is to minimize the measurement errors, okay, due to liquid and vapor mix. Another thing, DP transmitter itself is very sensitive. The load cell inside the DP transmitter is very sensitive. So if you are allowing steam to act directly in the contact of the DP transmitter, what is going to happen? It can damage it, isn't it? Because of continuously subjected to higher temperature. Okay. So second reason is that it will protect the DP transmitter from the effect of high temperature fluids.
सर
Please
पहला
write
वाला
down second.
फर्स्ट जो आपने बोला सर, एक बार फिर से बता दीजिए.
It will protect the sensitive electronic components of DP transmitter from high temperature. Third, eliminates the dirt, dust, sediment from entering the reference and variable leg.
सर ये डेंसिटी दोनों साइड सेम रहेगा क्या?
Exactly same नहीं रहेगा, but the phase will be same. Okay.
ऑलमोस्ट मतलब इसका कंसेप्ट सर यही है ना कि दोनों साइड सेम डेंसिटी
Yeah, if you look at
मिनिमाइज
the
रहेगा.
if you look exactly at the DP transmitter, at the inlet to the DP transmitter, the density is going to be almost same. But that is not the concept. The concept is if you are trying to measure one side vapor and other side liquid, your measurements are never going to be correct. So whatever errors are going to occur due to this different phase, that is eliminated with the help of your condensing pot. ठीक है, चलिए आगे.
हाँ सही सर, इसीलिए हम लोग पानी भर के रखते हैं ना पॉट में.
हाँ, उसके अंदर में पानी भरते हैं ना. Initially we require to fill with the water. Yes. So
ये स्टीम ड्रम में ही लगा रहता है.
हाँ, स्टीम ड्रम में लगा रहता है. तो यहाँ पे देखो, condensing pot, if you see, there will be filling plug. So initially at the time of commissioning, what we need to do, we need to open the filling plug and we require to fill the entire arrangement with the water. दोनों साइड पानी भरना है filling plug open करके. And the second point, it will also protect the sensitive equipment or electronic component of your DP transmitter from the effect of high temperature. Third thing, if some sediments, contaminants, or dirt particles are going to come, these are all going to be collected at the bottom of the condensing pot. Okay, it will not directly enter the reference leg or your variable leg. Otherwise, these particles, contaminants are going to make their way directly into these small diameter pipes and eventually they are going to choke it. So it is also going to ensure the cleanliness of the system by effectively eliminating any chances of sediment or dirt or dust getting deposited into these legs. Clear?
So in
Okay.
this diagram here is sir अपना condensing pot.
This is condensing pot, na sir?
Variable and who is the variable leg and constant leg, reference leg like that?
We'll come to that, no? We'll come to. Okay.
Okay.
So everyone is clear with this? Next is,
Okay, sir.
which is your reference leg? Reference leg is the leg which is connected to the steam side. What is your variable leg? Variable leg is going to be the leg which is connected to the water side.
Water side.
Then there will be isolation valves in case you require to repair, replace, or calibrate your DP transmitters. The isolation valves are provided. On each condensing pot, there will be drain valves provided. And during the calibration process, you require initial commissioning and calibration purpose. You require to equalize the pressure across your DP transmitter. So in between, equalizing valve is also provided. And finally, it is your DP transmitter. Clear with this one? Arrangement, general arrangement?
Yes, sir.
Sir, why this use? What is the function of equalizing valve, sir? What's it?
Equalizing valve, na?
Sir,
When
what is
you
this
going to
function?
open the equalizing valve, what will happen to the pressure across your DP transmitter?
Same.
It is going to equalize.
Yes, sir.
So during initial commissioning, we'll come to that one. Na? We'll come to that one. Initial commissioning and calibration time, you may require to keep the pressure equalized on both the sides.
Okay, sir.
Okay, let's move further. So initial commissioning of your DP transmitter. So let's go step by step here. First, before the boiler is pressurized and started for the first time, some initial commissioning procedures can be performed with regards to the valves of the DP water transmitter, shut-off valves, transmitter connection valves, and equalizing valve. should be operated in the following sequence during the initial commissioning. Step A, initial setting. All valves of the DP water level transmitter unit should be closed. Step B, open the equalizing valve located on the valve manifold. Step 3, unscrew the filling plugs for the reference leg and variable leg and fill the legs with water. ठीक है, यहाँ तक clear है सबको? Open the equalizing valve, open the drain plugs on the top of your
So this initial
pot.
setting, all valves of DP water level transmitter unit closed. That means on valve manifold. No, on this steam, on the steam on water side, right? This
Yes.
isolation valve.
इसको
Okay.
बंद रखो. Okay. Open this equalizing valve. Open the filling plug and fill the
fresh
water in this both side of the DP transmitter. Okay. Then open the transmitter connection valve and venting facility on the reference leg side of the transmitter. Okay. इसको खोलो connection valve. Where is the connection valve? These are the connection valve. Open this connection valve. So now water is going to be available all the way till DP transmitter, but the pressure is going to be equalized because your equalizing line is open. And if you look here, on both the side, this variable leg and the reference leg both are going to be provided with certain क्या है उसके अंदर में slope is there. Okay, at least 5 degrees of slope is required. What is the purpose of this slope? To remove the air. Okay, the slope is going to be positively ensuring air can be displaced and vented out from the vent plug. Initially, you are going to keep your vent plugs open. Understood? So open the transmitter connection valve and venting facility on the reference leg side of the transmitter and vent out all the air. After air is being vented out, close the venting facility on the reference leg of the transmitter when no more air is going to escape. Open the venting facility on the variable leg of the transmitter and close the transmitter connection valve on the reference leg side when there is no more air. So दोनों side में क्या निकालना है आपको? Open the vent plug and remove the air. यहाँ तक clear है? Step
filling plug है ना सर?
Filling plug है सर ना? Filling plug. चले आगे? Okay. Open the transmitter connection valve on the variable leg side of the transmitter. Close the venting facility on the variable leg side of the transmitter when no more air is going to escape. Okay, यहाँ पे सब कुछ है. एयर निकालने का प्रोसीजर बताया. ठीक है. अभी उसके बाद में क्या करना है? Close the equalizing valve. Okay, and after closing the equalizing valve, refill the legs with the feed water and screw on the filling plugs for the reference leg and the variable leg. So during initial commissioning, simple understanding is that you required to fill the water in the variable and reference legs and you required to vent out the air. वही तो procedure था, yes or no?
Yes sir, yes sir.
While keeping these valves shut, right, sir? Both
Yes.
valves.
इधर ये दोनों वाल्व को बंद रखो. Okay. Initially, fill the water. Keep your vent plugs open. Once water is being filled, then you are going to close the equalizing valve. Open this connection valve. Now water is going to be available on both sides of the DP transmitter. If there is possibility of some small air pockets, let it again vent out and again you are going to fill it. Okay, fill the condensing pot. Condensing pot को फिर से भरो, refill करो. Okay, so that way now on both the side of the DP transmitter you are going to have water. There is no air and your equalizing valve is now closed. यहाँ तक clear है? That is your initial commissioning. All right, now it's time for the calibration. There are two types of calibration. One is the blind calibration and one is the live calibration. What is the meaning of blind calibration? और आपको एग्जाम में ऐसे ही बोलना है सर. Okay, when you go for your examination, do not read your Google and all these things, ये आप अपना बॉयलर का पढ़ो क्या है, what is given in your boiler. Do not go with the Google and what the ChatGPT says.
Yes, sir.
That information is also correct, लेकिन वो that information is going to be varying and
Particularly,
discovered.
sir, particularly in Chennai MMD, they ask purposefully. They asking, have you read in your manual?
तो क्या होता है, आप तो when they ask you for the calibration, you can go with the Google answers, you can go with the ChatGPT answer. I am not saying that answers are wrong. Answers are correct, but are they relevant to your application? That is important thing, because DP transmitters are used for n number of application. They are used to measure the flow, they are used to measure the temperature, they are used to measure the levels, they are used to measure the pressures. All number of applications are there. तो किस type का calibration किसके लिए applicable है, that is required. So please follow this procedure. So in the blind calibration, what you are doing, differential pressure transmitter can be performed if no pressure source is available. This means when the boiler cannot be operated at normal working pressure. Clear? What is the blind calibration? Where there is no pressure source. That means the boiler is not pressurized. Due to some reason, you are not having pressurized boiler. Under that condition, you require to calibrate your DP transmitter. So how you are going to do that one? The water level cannot be increased and decreased. You cannot simulate that one. तो उस टाइप पे आप blind calibration करोगे. The start scale and full scale differential pressures are calibrated on the basis of calculated values. So here we require to go for mathematical calculation. Okay, the start of the scale value should be calibrated to obtain a 4 milliamp output signal. Where you are supposed to receive the 4 milliamp signal, where you are supposed to receive the 20 milliamp signal, that is required to be understood here. So 4 milliamp signal कब आना चाहिए? When the water level is going to be
low.
Okay, and when water level is going to be high, you are supposed to receive 20 milliamp signal. That is well understood. So how you are going to do that one? That you require to go with the practical or mathematical calculation. Okay, mathematical calculation करना पड़ेगा. So for the same purpose, let's look at here. Okay, this arrangement here. Now in this arrangement, please look into the temperature and density. Right now, we are calculating for 7 bar pressure. Okay. We are calculating for 7 bar pressure. We are assuming that ambient temperature of engine room is 40 degree. Corresponding to 40 degree temperature, the density is 992.2 kg per meter cube. Okay. So we have to calculate the difference. So let's assume that your water level is low, and then we are going to calculate the difference in pressure. What is the formula for difference in the pressure? का formula क्या है? Rho GH. Yes, G is constant on both the sides, so we are going to eliminate the G. So we are going to focus only on density and head. So let's say this is your DP transmitter. On this side, on this side, what is the pressure acting on the DP transmitter? This is entirely full with the water. Yes.
Density multiplied by height.
Density multiplied by height. So let's assume that height is H1. Okay, this height is H1. From this to this, the height is H1. And density is, let's say, rho 1. So what will be the pressure here? Rho 1, H1. Everyone agree? इधर क्या pressure आएगा इस side में?
ρ1 H1 सर। हाँ
ρ1 H1।
सर ये ब्लाइंड मेथड ही कर रहे हैं ना अभी।
हाँ ब्लाइंड से कर रहे हैं अभी, मैथमेटिकल कैलकुलेशन से कर रहे हैं। आपका स्टीम टेबल रहेगा, स्टीम टेबल में ये सब इंफॉर्मेशन रहेगा, 40 डिग्री पे कितना डेंसिटी है एंड ऑल दिस थिंग, इजंट इट? ओके, बोलो इधर साइड में, दिस साइड व्हाट विल बी द प्रेशर?
सर आपने जो ये वाटर लेवल लिया है वो रेफरेंस लेवल, मतलब वो अगर कम ज्यादा है वो तो आप ड्रेन करके उसको इतना पे वाटर लेवल लाएंगे।
हाँ, वी आर गोइंग टू ब्रिंग द वाटर लेवल टू दिस पॉइंट, लोएस्ट
लोअर।
लेवल।
ओके सर।
So now we know this distance. What is this distance? We are going to consider this distance H2 between two condensing, sorry, from the upper connection to the DP transmitter, the distance is H1. Between the condensing pot connection, the distance is 525 mm. तो इस साइड में देखो क्या आएगा, what will be the total head acting here?
The H1 minus S2 और इंटेंसिटी जो H1 minus S2 हो जाएगा ना।
इधर कितना हेड आएगा? इतना हेड आएगा, बराबर है। क्या है वो?
Only H2.
H2 into
डेंसिटी।
ρ2
हाँ, क्या डेंसिटी रहेगा ये पानी का? सेम डेंसिटी।
water. Yes sir.
ρ1
It is also subjected to atmospheric condition, so it is also having same density, and then it will be H2. Please. Okay, तो क्या कैलकुलेशन आएगा? Differential pressure is going to be, sorry, density भी same रहेगा, H2 will be different. H1 minus H2. What is your H1?
total height.
Total height.
525.
So
Okay.
H1,
Water level.
correct. So H1 is given, कितना है? H1 and H2 दोनों का डिफरेंस कितना है? 525.
Yes sir. H1 minus H2 525.
What is the density? 992.2 into 525. तो कितना आएगा? 521 mm of water column.
Water level, water column.
So you can convert into millibar, you can convert into PSI, whatever you want to do. But what is the differential pressure? When you get a differential pressure of 521 mm of water column, what should be the output signal your DP transmitter should produce? It should produce
4 milliampere.
4 milliamp. तो मैं क्या करूंगा? I will, because there is no boiler. Please remember, there is no boiler. This is all your calculation, theoretical calculation.
सर एक मिनट सर, ये 4 एम्पियर जो अभी 521 mm of H2O जो आया डिस्पेंसर प्रेशर, तो अभी 4 एम्पियर में क्या वाटर लेवल नॉर्मल ये कहलाएगा या लो कहलाएगा?
लो पे सर ना, अभी वाटर लेवल किधर है आपका? इधर है ना।
ओके,
तो ये
मतलब
लो
ये
हो
4
गया ना।
मिलियन, मतलब ये इतना प्रेशर 4 मिलियन पे लो लेवल।
When the DP transmitter will have differential pressure of 521 mm of water column, कन्वर्ट करो ना, वाटर कॉलम को आप बार में कन्वर्ट कर सकते हैं, PSI में कन्वर्ट कर सकते हैं, yes or no?
Yes sir.
So differential pressure of 521 mm of water column, what should be the output signal from the DP transmitter? It should be 4 milliamp, corresponding to low water level. अभी मेरे पास बॉयलर है क्या? I don't have boiler. This is all I have done theoretical mathematical calculation. So what I am going to do, I am going to apply, I am going to connect my pressure calibrator. Okay, I am going to connect the pressure calibrator to the DP transmitter, and I am going to apply the pressure. कितना pressure apply करना है? How much pressure? One side you are going to keep it open. See, One side you are going to keep it open to atmosphere. Okay. And one side you are going to connect to the pressure calibrator. And how much pressure you are going to apply? 521 mm of water column. So what will happen? Output signal will be, should be 4 milliamp. But if it is not 4 milliamp, let's say it is showing you 5 milliamp. So what do you require to do? You require to adjust the zero setting. So if you look into the DP transmitter controller, there will be two knobs. Okay, zero setting and span setting. So how much you have applied differential pressure? You have applied differential pressure corresponding to 521 mm of water column. Corresponding to that, you should receive the signal, output signal of 4 milliamp. If it is not generating signal 4 milliamp, what you are going to do? With the help of screwdriver, you are going to adjust your zero setting knob till the time you are going to get a 4 milliamp output signal. Everyone is following me?
Yes, sir. Sir, these
So that
knobs
is
are
called,
adjusting the strain gauge, no? Strain gauge output.
they are adjusting your output, sir. Okay, not the
Sir,
strain gauge.
no, sir. This DP से DP transmitter जो diaphragm है उसका जो pressure calibrator लगाया आपने 521 वो आया. अगर वो 4 की जगह 5 दिखा रहा है, it means problem with this strain gauge, no, sir?
It is not problem with the strain gauge. It is corresponding to that much strain. It was generating 5 milliamp signal. तो आप क्या कर रहे हो? You are programming your controller to give the output signal of 4 milliamp corresponding to that strain. You are not changing the strain. Please remember, strain वही रहेगा. What you are changing? Corresponding output. Understood?
Just
Yes.
setting change करना पड़ेगा.
हाँ, उसका आपको क्या, आप मान लो कि आप उसको क्या बोल रहे हो कि भैया इस ट्रेन पे 5 मिली एम्प मत दो सिग्नल, कितना दो? 4
चार
मिली
हो.
एम्प दो. ओके, 4 मिली एम्प. दैट यू आर एडजस्टिंग. क्लियर? चले आगे.
Yes.
ओके.
सर ये अपना 7 बार है और अपना तो ये बार होना चाहिए ना, बार्ज लिखा है 170 at 7 bars. I think it is bar, no?
बार वो गेज रीडिंग में है, इसीलिए ऐसे लिखा है.
गेज रीडिंग सर. हाँ, गेज रीडिंग.
ओके.
आप इधर इसको जितना सिंप्लीफाई रखोगे, हाँ, that will be easy to understand. All right. Next is, look at here. Now the next calculation. Your level, you are going to assume that. Okay, you are going to assume the level to the highest point. Okay, highest point. So that time, corresponding to what you are calculating, 7 bar के हिसाब से calculate कर रहे हो. You people are calculating corresponding to 7 bar. So look at here. Now what will be the pressure on this side of the DP transmitter?
Rho 1 plus Rho 1 into H1.
Same thing, na? Rho 1 into H1. What will be the pressure acting on this side? ये height
Rho
कितना
1
है? What is this height? This height is your
H2.
H2. This height is your H1. This is your
H1 minus H2.
H1 minus H2. Now, when you are considering this side, now you have to be careful because the density is going to be different. What will be the density of water that is acting in this variable leg? It will be corresponding to atmospheric condition. Yes. So it is going to be what? Density 1 only. भैया आपका आप क्या कर रहे हो? You are assuming your water level is up to this point. That means there will be two heads acting. One, the head which is being acting in the variable leg. What will be the density of that head? बोलो. वो तो density 1 ही आएगा क्योंकि वो pipe किधर है? Where is that pipe? It is outside the boiler and it is exposed to the atmospheric condition. But there will be also additional head here. Yes. इधर एडिशनल हेड भी है ना, इधर देखो
Yes, sir.
टोटल हेड इतना है.
H1 minus H2.
So what is the distance? Distance is going to be H1 minus H2. Okay, this distance. What will be the density?
Density तो same ही है ना sir.
क्यों सेम रहेगा? अभी बॉयलर के अंदर में जो पानी है वो तो गर्म रहेगा ना, corresponding to 7 bar pressure. What is the temperature of water in the boiler corresponding to 7 bar pressure?
170.
170. What is the density corresponding to 170?
897
8, 9,
तो
7
इसका
HP.
डेंसिटी अलग हो गया, ये डेंसिटी अलग हो गया. ओके,
Okay, तो row 2 हो जाएगा.
तो इधर टोटल कितना हेड एक्ट कर रहा है? टोटल हेड एक्टिंग ऑन दिस साइड इज
2.
रो 1 into H2
H2
H2 only,
plus
yes.
plus
row 2
row
into
2
H1
H1
minus
minus H2.
H2. So if you are
So-
going to put into the equation, okay, let's put it in the equation.
Okay, sir.
This is your row 1 minus H1, that is the pressure acting on this side,
Is
minus
equal to
equal to minus ये pressure इधर ना, minus row 1 H1 plus row 2 into H1 minus H2. If you are going to resolve this, what you are going to get? H1 minus H2 into
row 1 minus row 2.
density 2. You know the values. H1 minus H2 is how much?
525 mm.
5. Density difference 0.9922 minus 0.8970
8596.
for 8596. Okay,
8596. हाँ.
नहीं वो corresponding इसका लेना है ना हमें, 7 बार का लेना, not 16 बार. Corresponding to 7 बार. See,
Okay, sir. ठीक है, sir.
तो कितना आएगा ये? 50 milli
897.0.
50 mm of water column. Corresponding to 50 mm of water column, how much should be the output signal?
20 milliamps.
20 milliamps.
High level alarm.
तो आप क्या करो? You are going to apply the DP transmitter के. This is your mathematical calculation. You are going to keep one end of the DP transmitter open. This end को open रखो and connect DP your pressure calibrator on this end and apply the pressure of
20
50
mm of
mm of
H2.
water column. It should generate 20 milliamp signal. If it does not generate 20 milliamp signal, span calibration is there. Yes, there will be two knobs, one for zero setting and one for span setting. Adjust the span setting so that corresponding to 50 mm of water column, the DP transmitter will produce the equivalent signal of 20 milliamp.
Understand.
That is called your blind calibration, where pressure source is not available, your boiler is not there. But
सर आपने जो बताया वो समझ में आ गया सारा कुछ. इसमें क्वेश्चन क्या पूछता है सर?
calculate calibration. They ask you directly calibration of DP transmitter.
ये blind calibration कैसे करती है?
Yes, how the blind calibration can be calculated. So what you are going to say? Depending upon temperature and density, differential pressure across DP transmitter is calculated, and corresponding to that differential pressure, the output signal is, क्या करेंगे output signal को? Output signal is adjusted for 4 milliamp to 20 milliamp
20 milliamp.
by span
Zero
setting
setting
and
and span setting.
zero setting. Okay, तो लिख लो
सर
इसको.
लास्ट में आपने बोला सर किधर लिखा है कि बस
मैं
लास्ट में
लिख रहा हूँ.
पॉइंट बोला.
लिख रहा हूँ live
बाकी
calibration.
कैलकुलेशन समझिए बोलने के.
सर स्पैन सेटिंग एक बार बता दीजिए ना.
मैं बताता हूँ. The differential.
सर ये लाइव कैलिब्रेशन मतलब ब्लाइंड कैलिब्रेशन, राइट सर?
Blind है ना सर ये blind है.
Sorry, blank calibration. Blind, not blind.
ये blind calibration टोटल ऐसा फैक्ट्री में होता है ना, ये मतलब बॉयलर सेट करके नहीं है.
इसको लिखो. Blind calibration is applicable when no source of pressure is available.
Means it is not fitted on the boiler, sir.
It is not fitted. It is all
On
on the
factory.
theoretical and mathematical calculation. The differential pressure across the DP transmitter is calculated depending upon the pressure and relative temperature. किधर से मिलेगा? आपको कैसे मालूम कि 7 बार पे 170 डिग्री टेम्परेचर है? This information from where you are
Steam
going to
table.
PT chart, sir.
PT चार्ट पानी के लिए नहीं होता है, उसको स्टीम टेबल रेफर करना पड़ेगा.
Okay, sir.
तो क्या लिखा है? Differential pressure across the DP transmitter is calculated depending upon the pressure and relative temperature and the output signal for low water level and high water level is adjusted to 4 milliamp and 20 milliamp respectively by 0 and span setting. This is done by keeping one leg of DP transmitter open to atmosphere and connecting one leg pressure calibrator. तो आपको mathematical
One
calculation
leg मतलब reference leg will be like open to atmosphere, right? So,
yes, ठीक है. इधर का लेग आप ओपन रखो एंड इधर का किसको कनेक्ट करो? कैलिब्रेटर को. ओके, प्रेशर कैलिब्रेटर को. ऑलराइट. So nobody is going to ask you the mathematical calculation. That is for your understanding when you go on ship and if you encounter any problem in the DP transmitter. I hope if you understand this, you will be able to resolve the issue or you will be able to calibrate the DP transmitter without any problem. Okay. आपको एग्जाम में क्या बोलना है? Only this is required to be said. Okay. अभी लाइव कैलिब्रेशन में क्या करेंगे? What we are going to do in the live calibration? We are going to practically, this is your two sides of the DP transmitter. Okay. आप क्या करो? Practically you are going to increase the level. You are going to bring the level first to this. Okay. You are going to practically bring the level to low level and you are going to adjust the output signal from DP transmitter to be read as 4 milliamp.
सर लाइव कैलिब्रेशन में भी सेम कैलकुलेशन करना है बट प्रैक्टिकली करना है.
आपको कैलकुलेशन कुछ नहीं करना है ना? You
तो
don't
steam
require to do
table पे हो
calculation.
जाएगा.
सर
You are practically doing ना? Practically you are
Yes,
going to
sir.
bring the level to
पैरामीटर
low
कैसे
water
मिलेगा
level.
सर? लाइव में पैरामीटर्स कैसे मिलेगा? जैसे डेंसिटी कैसे?
क्यों चाहिए आपको पैरामीटर? Nothing is required. You are
डेल्टा
going
भी
to
निकालें.
you are going to keep the pressure to 7 bar and you are going to bring the level to low water level. DP transmitter should produce 4 milliamp signal. If it is not producing, adjust by 0 setting.
Okay.
Then you are going to raise the level to high water level, DP transmitter should produce 20 milliamp signal. Okay, नहीं produce कर रहा है तो adjust
Sir,
by
just one question. Sir,
span setting. Yes.
when we are at the low level alarm, then it means the pressure is also getting low, right? Then how it will maintain 7 bar? Like, say for example, sir, for auxiliary boilers, the pressure we maintain is 5 to 6 bar, right? 6 bar, 7 bar. So when we are at the lower level or the low level alarm comes, the pressure falls.
क्यों pressure fall होगा? Level and pressure are two different things, na? Yes or no?
Sir, you are asking about the
If you are
column
okay,
or the
I got your point. You require to keep the pressure constant, even though you are going to bring the water level to low level.
Yes, sir.
But fire your boiler and keep the pressure 7 bar. Okay, understood?
Okay,
you have to bring the pressure to 7 bar. This is your practical approach. Okay, practical approach. What is your working pressure? Working pressure is 7 bar.
Yes, sir.
तो उस corresponding pressure पे आप दो जगह पे adjustment करो, bring the water level to low level and bring the water level to high level. That's it.
Okay, sir. Okay.
Slight
So,
variation in the pressure is acceptable. That is going to mimic
this
the
level
exact.
is achieved at low level and high level. Those will be verified by the gauge glasses, right, sir?
Yeah, gauge glasses. Correct. Absolutely correct.
And sir, we have to maintain the same pressure on the low level and the high level. Then only calibration is right.
Try to maintain as
Same
much
to-
as close to the value, because this is your practical adjustment of the DP transmitter. Okay, आपका working pressure कितना है sir? 7 bar है. But what you are interested in? Low level. Okay.
Yeah.
So bring the water level to low level. Pressure can be slightly up down. Acceptable, not an issue. Understood? तो
Okay, sir.
उसमें सेट करो 4 milliamp. Output signal should be 4 milliamp. नहीं है, zero setting adjust करो. Then increase the water level to highest point. Okay. And then output signal should be 20 milliamp. नहीं है, adjust your span setting. So this is your practical approach. And most of the time,
Sir, what is span setting, sir? How we do?
if
20
you
wala.
open the DP transmitter,
maximum setting and minimum setting होता है.
there will be two knobs will be there, which can be adjusted by screwdriver. One will be Z and one will be yes. आपने क्या किया? You have taken your level to low water level. Corresponding to low water level, output signal should be 4 milliamp. But if it is not 4 milliamp, for example, it is 7 milliamp. So what you are going to do? You are going to adjust this setting here with the help of screwdriver till the time the output signal is going to be 4 milliamp. Okay. Span में क्या होता है? Span is going to tell you the range of calculation. So what is your range? You are measuring the range. This one, you are measuring the change in the water level between this range. So this is your minimum and this is your maximum range. So when water level is going to be at the highest point, that time the output signal should be 20 milliamp. If it is not 20 milliamp, it is something else. For example, 16 or maybe 18 or maybe 15. So what you are going to do? You are going to adjust the span setting in such a way that output signal at highest water level is going to be 20 milliamp. That is called your span and zero calibration. ऐसे तो करते हैं ना, हर जगह पे रहता है ना. You are, even though you are having your what we say,
blind
control.
Yes.
Control walls are there. They are also working on the same principle. You are doing span setting, adjusting your zero calibration. Okay. So by doing this one, what you are going to get? If I am going to plot a graph, yeah, I know that okay, ये मेरा 4 milliamp है. Okay, this is my 20 milliamp. At 0 milliamp, what is the level? Low
Minimum.
level.
No.
High level. So can I calculate? For example, my DP transmitter is giving 12 milliamp signal. Can I calculate the level? What should be the corresponding level? Yes. Isn't it? I get this graph ना. ये graph मैंने draw किया. So I can predict any intermediate position with the help of this particular curve. Is it understood?
Yes, sir. Sir, थोड़ा
Sir,
scroll down कीजिएगा
now,
sir. Screenshot.
now,
Blind
sir,
one.
blind calibration is to be done when there is no source of pressure is available.
Yes, no source. You can do it in a workshop also. Take the DP transmitter to the workshop, calibrate it, install it. क्या देखना था सर आपको?
ये blind वाला को थोड़ा सा एक शॉट में थोड़ा सा एक
और सोचो ऊपर में
ये मैं भेजता हूँ ग्रुप में भेजता हूँ यार, वो छोटा नहीं हो रहा है, ठीक है?
Okay,
Sir, just
Thank
one
you.
last doubt. Sir, so span setting is for the DP for the device.
For the range.
For the
Okay, for the range. And zero setting is for
output signal.
lowest possible. For example, if you want to read, let's say you are measuring pressure. Okay. If you are measuring pressure and you want to measure the pressure between 10 bar and 20 bar. So corresponding to 10 bar, what should be your signal?
4 milliamps.
4 milliamp. That means you are able to read your lowest possible pressure with the help of 4 milliamp. But what is your range? You want to measure between 10 to 20 bar, isn't it?
Okay, sir. Understood.
So what is your span? Span क्या हो गया आपका? 10 बार से लेके 20 बार के बीच में. Okay. So what you are going to do? This is going to be your 10 bar and this is going to be your 20 bar. Okay. This is going to be your span. Okay. This is your span. So जो आपने अगर maximum output को corresponding अगर or whatever the maximum value you are trying to measure, corresponding to that maximum value, if you are going to adjust your DP transmitter to generate an output signal of 20 milliamp, and whatever is the lowest value you are trying to measure, it may be pressure, it may be flow, it may be temperature, it may be anything. So you are going to adjust your controller to generate 4 milliamp signal. So I can always draw this line. Can we draw this line?
Yes, sir.
Yes, sir.
And I can also predict, let's say 10 milliamp pe, for example, wall opening. The wall is going to open how much percentage? I can calculate, no? Yes. This is your, for example, 0% opening, and this is your 100% opening. So let's say my output signal is 10 milliamp. तो मैं ये 10 milliamp के लाइन पे देखूंगा कि वॉल कितना ओपन है. Yes, maybe 30% it is open. Understood? So this way, a lot of things can be done by plotting this graph. A lot of information can be obtained for the intermittent operating points.
और एक डाउट था सर, ये वेरिएबल है और ये जो दूसरा लेके उसको वेरिएबल क्यों बोलते हैं सर? कोई रीजन है क्या?
Reason है ना, because variable, what is varying in the boiler?
Pressure is
water level is varying, na? What you are trying to measure here? You are trying to measure the water level. So what is varying? Water level vary हो रहा है ना, low to low, between low and high. So the leg which is connected to that side, that is called your variable leg. Head is changing, na? Where head is changing?
Variable leg.
Variable side, na? Is it changing on the reference side? It is always constant, na? Then rho 1 into h1. Yes or no? अरे अभी तो calculation देखा हमने. It is not going to change. Which part is going to change? यहाँ पे देखो, ये change हो रहा है क्या? Is it this value changing? No, this value is not changing. What is changing? इधर में ये level change हो रहा है. This is always going to remain same. That is why it is reference, and this is variable. Clear? Okay. Now one homework.
Yes.
Okay, one homework to everyone. If equalizing wall is open, what will be output from DP transmitter? Okay, ये homework है आपके लिए. So I hope those people who understand the concept, they can find the answer for this one without any difficulty. Okay, this is homework for you guys for tomorrow. So see you tomorrow. I have to go somewhere
सर
very
ऊपर
urgently.
थोड़ा कीजिएगा सर, यहाँ क्या लिखे तो समझ नहीं आ रहा है। थैंक यू सर।
If equalizing wall is open, if equalizing wall is open, what will be the output from the DP transmitter? That is the question.
सर यहाँ नहीं सर, ऊपर ब्लाइंड कनेक्शन में लिखो सर।
वो भेजा मैंने
Blind
आपको
color
ग्रुप में ना
है।
सर, आपको भेजा
नहीं
सब
सर, वहाँ कुछ लिखा हुआ सर, समझ में नहीं आ रहा सर। हाँ यहाँ लिखा हुआ ना सर, ट्रांसमीटर ओपन एंड ऊपर सर ये।
वो एग्जांपल के लिए दिया था मैंने, ठीक है ना? With the help of this particular graph, you will be able to determine position of your controller also, ठीक है ना?
तो
If
ड्यूरिंग
you know
रनिंग
what-
कंडीशन में इक्वलाइजिंग वाल्व खोल दिया ना, क्वेश्चन ये है मतलब।
हाँ, इक्वलाइजिंग वॉल खोल दिया आपने तो क्या होगा? That is the question. Okay, we'll discuss. If something is not clear, we'll discuss tomorrow also, guys. Okay, not an issue. चले, आज के लिए इतना काफी है. See you tomorrow, guys. Bye.
थैंक यू।